Welcome all to the chemistry's online class. In the previous class, we have discussed the specific conductance. Okay, specific conductance, its mathematical expression, and the units of specific conductance. And today, we are going to discuss and study the new concept of this chapter, electrochemistry part first. That concept is equivalent conductance. Okay, in the previous class we have discussed the specific conductance, and today we are going to study the equivalent conductance. Obviously, it is known that the conductance of any substance, that may be solid or liquid, that depends upon the length and area of that conductor, or in other words, I would say the conductance of any conductor is reciprocal of the resistance, and the resistance of the conductor depends upon the length and uh, area of cross section of that solution or conductor. Now, though the specific conductance is suitable, particularly it is suitable for the metallic conductance. Specific conductance, it is suitable for characterizing the specific conductance, but that specific conductance is not suitable for the electrolytic, for the characterizing of electrolytic conductance. What does it mean? Specific conductance, specifically it is most suitable or most used to determine the specific conductance. Okay, sorry, specific conductance is mostly used for the determination of conductance of metals, but that specific conductance property is not suitable for the measurement of equivalent conductance, measurement of electrolytic conductance. Okay, so the new property has to be introduced. The new property with greater significance has to be introduced to measure the electrolytic conductance. As we know that metallic conductors are broadly classified into two types: metallic conductors and electrolytic conductors, electrolytic solution conductors. Okay, but specifically the specific conductivity is used for characterizing the conductance of metals, but that specific conductivity is not exactly or properly suitable for the measurement of electrolytic conductance. That is why this term equivalent conductance, new property has been introduced. New property has been introduced for characterizing or for the measurement of electrolytic conductance. Why it is not, specific conductance is not suitable? Why is the specific conductance not suitable for the electrolytic conductance? Because we know that electrolytic conductance depends on various factors like the concentration of solution. One of them is concentration of solution, temperature, etc. That part we have already discussed in the previous or very first lecture, that the electrolytic conductance depends upon the concentration. Greater the concentration, greater would be the electrolytic conductance. But in case of metals, it is that conductivity does not depend upon as many as factors which depends upon the electrolytic, or electrolytic conductance depends upon these factors. Okay, that is why specific, instead of specific conductance, the new property, that is equivalent conductance, has been introduced. Okay, particularly this equivalent conductance is used for the measurement of electrolytic solutions conductance of electrolytic solutions. Now, what is mean by equivalent conductance? What is mean by equivalent conductance? To get into the details of equivalent conductance, I would like to, or let me know, do you know what is equivalent weight or gram equivalent? Do you have any idea about the gram equivalent weight? Or in other words, equivalent weight or gram equivalents are nothing but the same properties. Okay, gram equivalent or equivalent weight of the substance. Okay, we know the molecular weight. Okay, molecular weight is the summation of atomic weights of all the atoms from which the molecule is formed. That is known as molecular weight. And equivalent weight or gram equivalent weight is given as its molecular weight of that substance divided by its acidity, basicity, or its acidity or basicity. Now, what is acidity and what is basicity? Or it is not and or basicity. Basicity. Okay. What is mean by acidity of a substance? If the substance is base, then its acidity means how much molecule, how much moles of base can be reduced. That part is a very basic one, and you may have studied this in the 11th and 12th standard. So I would not go through that much detail in this concept. Just remember equivalent weight substance. For example, if I ask you to calculate the equivalent weight of sodium hydroxide, okay, NaOH, then the NaOH is a base substance. NaOH is a base substance, basic substance, and the equivalent weight of NaOH can be determined as equivalent weight is equal to its molecular weight divided by its acidity. Acidity is how much moles of H plus ions can be replaced by 1 mole of base. Okay, that is known as acidity. Now, molecular weight of NaOH is 40 gram. 40. Molecular weight of NaOH is 40 because Na 23, oxygen 16, and hydrogen 1. Total comes equal to 40. Therefore, molecular weight of NaOH is 40 divided by its acidity is 1 because one NaOH molecule can replace one H plus ion from the acid substance. Therefore, its acidity is 1. Therefore, the molecular weight of NaOH is equal to its equivalent weight also. If the basicity is more than 1, then the molecular weight and equivalent weight will be different. Okay? As long as the acidity or basicity of that substance is 1, then its molecular weight as well as equivalent weight will be equal. Okay? Therefore, the equivalent weight of NaOH is equal to 40. Okay? Equivalent weight of NaOH is equal to 40. So, this is the equivalent weight. Then what is mean by gram equivalent? Gram equivalent is the molecular equivalent weight of the substance taken into the gram, or equivalent, that much amount of substance is measured in gram, that is equal to gram equivalent. And 1 gram equivalent of NaOH, 1 equivalent of NaOH will be equal to 40 gram. Okay, understood? 1 gram equivalent of NaOH. NaOH is a substance, electrolyte. Okay, let us consider it is an electrolyte. NaOH is an electrolyte. Then 1 gram equivalent of an electrolyte is equal to equivalent weight in grams. Equivalent weight of that substance in grams. This is all about the 1 gram equivalent, because to understand this concept, equivalent conductance, in detail, we need to know that gram equivalent. That is why I explained that concept in detail. Now, equivalent conductance. What was the definition of specific conductance? Specific conductance, suppose in the last lecture we have already discussed specific conductance. The conductance of a solution, or the conducting power of the substance, which is having length 1 centimeter and area of cross section 1 centimeter square. Okay, 1 centimeter square of such a substance. Whatever the conductivity is there, that conductivity is known as specific conductance. Suppose there is a electrolytic solution. Okay, now out of this electrolytic solution, this the conductance of or the conducting power of all the ions present in 1 centimeter cube of the solution. 1 centimeter cube of the solution, that is the conductance of these ions which are present in that area only is said to be a specific conductance of this solution. Okay, if there is a 1 liter of solution, out of which the solution which is present in 1 cubic centimeter of the solution. Okay, 1 cubic centimeter मध्ये जेवढं सोल्युशन असतं फक्त तेवढ्या सोल्युशन मधल्या आयनची कंडक्टिव्हिटी म्हणजे काय स्पेसिफिक कंडक्टिव्हिटी स्पेसिफिक द नेम इटसेल्फ इंडिकेट्स the conductivity of the solution in a specific region in a specific ह्या शब्द देखील आपण मांडू शकतो that is a specific conductance but this specific conductance cannot be used properly appropriately for the measurement of conductivity of electrolytic solution. That is why this term has been introduced. Now, this equivalent conductance is defined as the conducting power please mute yourself. Someone is okay. Equivalent conductance is defined as the conducting power of all the ions of an electrolyte in a given of 1 gram I would say conducting power of all the ions present in a solution containing 1 gram equivalent of an electrolyte. Okay, in the conducting power or the conductance of all the ions which are present in a solution, which are present in a given volume of solution. If I make some correction in this definition, okay, the conducting power of all the ions which are present in a given amount of solution, in a given volume of solution, which consists of 1 gram of equivalent of an electrolyte. 1 gram equivalent of an electrolyte. एक सोल्युशन आहे त्याचं व्हॉल्यूम फिक्स आहे त्या सोल्युशन मध्ये किती इलेक्ट्रोलाइटचं प्रमाण किती आहे 1 ग्रॅम इलेक्ट्रोलाइट. दॅट 1 ग्रॅम इलेक्ट्रोलाइट तो इलेक्ट्रोलाइट कोणता आहे त्यावरून त्याचं 1 gram equivalent ठरतं. How much gram of electrolyte, how much gram of solute is present in the solution. Okay, that depends upon the nature of an electrolyte which we are going to use for making this solution. Okay, we are making the solution. The conductance, or in simple words, the conductance of such a solution which consists of 1 gram equivalent of an electrolyte. The conductance of such solution is known as equivalent conductance. Why equivalent conductance? Because in that given volume of solution, 1 gram equivalent of an electrolyte is dissolved. Okay, after complete dissolution, whatever the conductance shown by this solution, particular volume of solution, that conductivity is known as equivalent conductance. Okay, equivalent conductance. And mathematically it can be expressed as the equivalent conductance is represented by a symbol lambda, and and mathematically it is given as lambda is equal to K into P. K into P, where K is specific conductivity. Specific conductivity or conductance. Specific conductance of a solution, and V is volume of a solution. Total volume of a solution in which 1 gram equivalent is present. Okay, 1 gram equivalent is present. But we know that the K is the specific conductivity, and which is given as 1 upon R into L upon K. In the previous lecture, we have derived this equation. Specific conductance is equal to 1 upon R into L upon A, where R is the resistance of a conductor, L is the length of the conductor, and A is the area of cross section area of the conductor. Okay. Now, if we put this value in this equation, what we will get? Therefore, equivalent conductance of a solution is equal to, just put this value in this equation, what we will get? 1 upon R into L upon A into V. Okay, this is another form of equivalent conductance. This is the one form. And again we can write, if the volume of the solution is 1000 cc, if volume of the solution is 1000 cc, cc means cubic centimeter, or in other words, if the water is used as a solvent to make that solution, then we can to make this term simple, we can imagine cc stands for cubic centimeter, and that will be equivalent to ml, okay, milliliter. Now, if the volume is 1000 cc cubic centimeter, in which n gram of electrolyte, n gram of electrolyte is present, then this equation can be written as lambda is equal to what? 1 upon R into L upon A into 1000 upon L, where N is the concentration of solution. This is another form of equivalent conductance. Or in simple terms, we can write this equation in this form also. Lambda is equal to K into 1000 upon L. Why am I trying to express the equivalent conductance equation in different forms? Because if the numerical problem is asked in the examination, they don't ask the direct questions like calculate the equivalent weight of the solution whose specific conductance is so and so, and its the total volume of the solution and so and so. They will not directly ask to determine the equivalent conductance. Sometimes they provide the value of equivalent conductance and volume, and they ask you to calculate the specific conductance. Or sometimes they provide the value of R, they provide the value of L, A, and ask to determine the value of lambda. At that time, first of all, you have to calculate the specific conductance with the help of the given values of R, L, and A. Okay? Then, after determining the value of specific conductance, put the value of specific conductance in this formula, and then you can easily calculate the equivalent conductance. Okay. Overall, the equivalent conductance, once again I will repeat the definition. Equivalent conductance of a solution, electrolytic solution, is defined as the conducting power of all the ions present in a given volume of solution containing 1 gram equivalent of an electrolyte. Okay, if 1 gram equivalent of an electrolyte means which electrolyte? Electrolytes, what are electrolytes? I have already explained in the previous class. What are electrolytes? Electrolytes are the substances which gets dissociated, the substances which get dissociation upon dissolution. Okay, when that electrolyte is dissolved in a proper solvent, then it will get dissociated into ions. All such substances are said to be electrolytes. Now, these electrolytes, all kinds of inorganic and organic salts like NaCl, KCl, ferrous sulfate, iron sulfate, etc. All such kind of salts, they are electrolytes. Okay, and these electrolytes can further be divided into two classes. That part we will discuss after some time. And I hope it is clear to you what is equivalent conductance. If you have any doubt or problem, then once again I will try to explain it in Marathi. स्पेसिफिक कंडक्टन्स म्हणजे एका दिलेल्या सोल्युशन पैकी फक्त काही 1 ml सोल्युशनचं किंवा 1 क्यूबिक सेंटीमीटर एरियातल्या सोल्युशनची कंडक्टिव्हिटी म्हणजे स्पेसिफिक कंडक्टन्स. 1 लिटर सोल्युशन आहे त्यापैकी 1 क्यूबिक सेंटीमीटर एरियातल्या सोल्युशनची कंडक्टिव्हिटी म्हणजे स्पेसिफिक कंडक्टिव्हिटी. थोडक्यात आणखी सोप्या भाषेत सांगायचं असेल तर टोटल सोल्युशन मध्ये 1 क्यूबिक सेंटीमीटर एरियातल्या सोल्युशन मध्ये प्रेझेंट असणाऱ्या आयन नी दाखवलेली त्या आयनची कंडक्टिंग पॉवर. ओके, द आयन्स प्रेझेंट इन दॅट 1 क्यूबिक सेंटीमीटर shows the conducting power, and that conducting power is nothing but specific conductance, which is given as 1 by R into L by A. And what are these terms? Already we discussed in the previous class. Now, that is the specific conductance. Now, what is equivalent conductivity? किंवा ह्याचा हे काय इंट्रोड्यूस करण्यात आली? कारण स्पेसिफिक कंडक्टिव्हिटी पर्टिक्युलरली कोणती कंडक्टिव्हिटी, कोणत्या टाईपच्या कंडक्टरची कंडक्टिव्हिटी मोजण्यासाठी सुटेबल आहे तर मेटॅलिक कंडक्टर्स. जे कोणते मेटॅलिक कंडक्टर्स आहेत त्या सर्व मेटॅलिक कंडक्टरची कंडक्टिव्हिटी मोजण्यासाठी ती स्पेसिफिक कंडक्टिव्हिटी सुटेबल आहे. कारण का? त्या कंडक्टरची लेंथ, एरिया, रेजिस्टन्स ही फिक्स आहे, नोन आहे, एस्टॅब्लिश्ड व्हॅल्यूज आहेत. पण इलेक्ट्रोलायटिक कंडक्टन्स ही काय आहे? इलेक्ट्रोलायटिक कंडक्टन्स depends upon main factors, out of which the two are main: temperature and number of ions. Temperature and number of ions, or in other words, instead of number of ions, I would say that depends upon the concentration of the solution. If the concentration changes slightly, the equivalent conductivity, the electrolytic solution ची conductivity देखील change होते. त्यामुळे instead of using the specific conductance for the measurement of electrolytic solutions conductivity, new concept with greater significance has to be introduced. म्हणूनच त्या इलेक्ट्रोलायटिक सोल्युशनच्या कंडक्टिव्हिटी मोजण्यासाठी स्पेसिफिक कंडक्टन्स ही प्रॉपर्टी काहीशी सुटेबल नसल्यामुळे नवीन प्रॉपर्टीचं इंट्रोड्यूस करण्यात आलेलं आहे. ती प्रॉपर्टी म्हणजे इक्विव्हॅलंट कंडक्टन्स. इक्विव्हॅलंटचा अर्थ काय मी सांगितलेला आहे. इक्विव्हॅलंट स्टँड्स फॉर 1 gram of equivalent of the substance. Now, what is 1 gram of equivalent of substance? ते पण सांगितलेलं आहे. Equivalent weight of that substance measured in grams. फॉर एक्झाम्पल सांगितलं NaOH सांगितलं किंवा NaCl घेऊ शकता, HCl घेऊ शकता. NaCl घेतलं तर काय होतं? NaCl चं मॉलिक्युलर वेट किती आहे? Na चं 23, क्लोरीनचं 35. इफ यू ऍड जे टोटल येईल ते काय झालं त्याचं मॉलिक्युलर वेट. NaCl ची बेसिसिटी सुद्धा काय 1च आहे. म्हणजे काय झालं त्याचं मॉलिक्युलर वेट आणि इक्विव्हॅलंट वेट सारखंच आहे. त्या सबस्टन्सचं इक्विव्हॅलंट वेट ग्रॅम मध्ये घ्यायचं, तेवढं ग्रॅम त्या सबस्टन्सचं इक्वल टू 1 ग्रॅम इक्विव्हॅलंट. तिथं 1 ग्रॅम इक्विव्हॅलंट म्हणजे काय, 1 ग्रॅम ते सबस्टन्स नाही. तर many a times students get confused. 1 gram equivalent of NaCl, that doesn't mean you just take 1 gram of NaCl. Okay, असं आहे का नाही. 1 gram equivalent म्हणजे NaCl चा इक्विव्हॅलंट वेट जेवढं आहे ते ग्रॅम मध्ये तेवढं ग्रॅम NaCl घ्यायचं आणि 1 लिटर मध्ये सोल्युशन मध्ये डिझॉल्व्ह करून त्याची कंडक्टिव्हिटी मोजायची, जी ती काय असते, इक्विव्हॅलंट कंडक्टन्स. ओके, take for example, if I ask you to prepare 1 gram equivalent of 1 gram equivalent solution of 1 liter of 1 gram equivalent solution of NaOH, then you have to take accurately 40 gram of NaOH, then dissolve this much amount of NaOH in water and make that solution up to 1000 ml or 1 liter. That will be a 1 liter solution of 1 gram equivalent of NaOH. Okay, 1 gram. तिथं किती 40 ग्रॅम 1 लिटर मध्ये डिझॉल्व केल्यानंतर जे सोल्युशन तयार होतं त्याला काय म्हणायचं, 1 लिटर सोल्युशन ऑफ gram equivalent of NaOH, 1 gram equivalent of NaOH. Okay, now I hope it is clear now. Only 10 minutes are left. So म्हणजे समजलं आता, specific conductance, it is the conductance shown by the solution which is present in 1 cube centimeter. Okay, and what is equivalent conductance? Equivalent conductance is the conductivity shown by all the ions present in a V ml of solution or present in a given solution which consists of 1 gram of an equivalent, 1 gram equivalent of an electrolyte. That conductance is called equivalent conductance. And now I would like to focus on another concept which is very easy and small one also. So within 10 minutes we can cover it. That is why I will take that point first of all. What are strong electrolytes and weak electrolytes? That part we will discuss first, and tomorrow we will discuss what is the effect of dilution on the specific conductance and equivalent conductance. Okay, that part we will discuss that one. But first of all, electrolytes. Okay, now what are electrolytes? Electrolytes are the substances which get dissociated upon dissolution in a proper solvent. असे सबस्टन्सेस सॉल्व्हेंट मध्ये एका प्रॉपर सॉल्व्हेंट मध्ये डिझॉल्व केल्यानंतर त्यांचे आयन्स तयार होतात. अशा सबस्टन्सेसला काय म्हणतात, electrolytes. Not only they dissociate into ions, as they dissociate into ions, and if we pass the electric current through such a solution, then that ions conducts the electricity. That ions carry some amount of electricity along with them and move towards the respective electrodes. Such substances are said to be electrolytes. Now these electrolytes are classified into two types. One are strong electrolytes and another type is weak electrolyte. I hope you can see what I written on board. Okay, electrolytes are classified into two types: strong electrolytes and weak electrolytes. Okay, electrolytes, the substance which get dissociated into the solution. Okay, or in other words, the substance which can form the ions upon dissolution in a proper solvent. Such substances are said to be electrolytes. Now they are categorized into two types depending upon their dissociation, whether they completely dissociate or partially dissociate into the solution. Depending on this fact, these are classified into two types. An electrolyte which completely dissociate into the solution are called strong electrolytes. strong electrolytes. And there are some substances are said to be the electrolytes. There are some electrolytes which do not dissociated into ions completely. They do not completely dissociate into ions. Such are said to be weak electrolytes. Weak electrolytes. Understood? For example, uh, yes. Have you done the practical in the last year that solubility of benzoic acid increases with increase in temperature? Okay, if you try to dissolve the benzoic acid in water, only a fraction of benzoic acid will be soluble in water, and rest of the benzoic acid will remain in the water in the solid state in its original form. Means only few of the benzoic acid will get soluble. Therefore, benzoic acid is said to be weak electrolyte. Okay, meet sodium chloride. Okay, sodium chloride salt. If you dissolve in water, as soon as you add into the water, all the sodium chloride salt gets completely dissociated. You will not find any fraction of solid NaCl in this water. Okay, in the water. Therefore such electrolytes are said to be strong electrolytes. Okay, I hope it is understood that it is clear to you that strong electrolytes, the substances or electrolytes which completely dissociates into the solution, and the weak electrolytes are the substances which partially dissociate into ions, which are partially soluble in solvent. These such electrolytes are said to be weak electrolytes. How much time is left? I can't see on the board. So go. Okay. I will close first of all. Okay, now the examples of strong electrolytes, almost all salts. Okay, almost all salts of organic and inorganic compounds, they are completely dissociated. They get completely dissociated to proper solvent. Therefore, all kinds of salt. For example, NaCl, KCl, BaCl2 or HCl, all strong acids also. Okay, all strong acids. What are these acids? HCl, HNO3, nitric acid, H2SO4, sulfuric acid, etc. etc. And weak electrolytes are all organic acids. All organic acids. All organic acids. These are mineral acids, HCl, HNO3, H2SO4, etc. Okay, and also we can make it here all bases: NaOH, KOH, barium hydroxide, calcium hydroxide. You can put a lot of many more. Okay, but these weak electrolytes are all organic acids like oxalic acid, benzoic acid. Acid, very importantly, acetic acid, etc. Okay, these substances are said to be weak electrolytes because if you add acetic acid into the water, then complete acetic acid will not dissociate it into ions. Only some of the part of acetic acid will get dissociated, and some of the part will get remain undissociated. Now these classes are divided into two classes depending upon this fact. Okay, completely dissociation or partially dissociated. Again, this can be classified into two classes depending in the same. Again, these electrolytes can be classified into two same classes based on the fact that whether the rate of dissociation is fast or slow. Okay, if the electrolyte dissociate into ion at a very high speed, as soon as you add into the solution, they get completely dissociated with a high rate. Such are also said to be strong electrolytes. And if the rate of dissociation of the compound is very slow, slowly त्याचं आयनायझेशन होत असेल तर अशा सबस्टन्सला काय म्हणतो आपण weak electrolytes. I hope this concept is also clear to you. And now I ask you, if you have any doubt, then you can raise your concern. You can ask straight away. Yes. If you have any doubts, you can ask.